Hello and welcome. Today we'll start with section 2.1. We're working on sets. We have an introduction to sets. So first off, what we mean by a set is just a collection of objects. So that can be anything. Typically in a math class, of course, we would more often work with sets of numbers, but we can be working with sets of chairs, people, planets, anything. So some typical ways that we would describe sets. One would be in what's called roster form. Or roster notation. So we give the set a name. This is typically a capital letter. So M might be the set of months of the year. So we could have January, February, etc. Now, if you have a bigger set and you don't want to list everything, but there is some definite known pattern, you can put in an ellipsis to say that this pattern continues. So between the two commas, we've got the ellipsis, and we just tell the reader where it stops. So in this case, it stops at December. So just like a roster on a sports team or a class roster, a list of all of the members of that set. Yeah, if I pick out, let's do a different set. We'll call this set A and have elements lowercase a, b, c. If you are someone that uses either all uppercase or all lowercase, one, that's not a good habit anyway, but two, you definitely don't want to use that working with sets. Cap A here is the set of these three elements. Lowercase a is element A. These are not the same. So make sure you're distinguishing between the upper and lower case when we have the same letters used. When you're in roster notation, you can switch things up unless you're using an ellipsis. So I could also have expressed set A as B, C, A as well, and those still are the same. So the order is not important, save for using the ellipsis. So as I mentioned, more often in a math class, of course, we're more interested in sets of numbers. So we'll start with the first set of numbers that we as humans discovered. We went from being just nomadic to actually settling down and farming instead of just being hunter-gatherers. And that would be the set of natural numbers. So a cap N, usually there's one additional line. Sometimes people do it on the vertical, some people do it on the diagonal. And that, just like you would expect, so we have the brace opening it, we just start at 1. So once they had one object, 1 ear of corn, there was 1. 2 ears of corn represented 2, and so on. Early on, it was just sort of counted with things like a pebble and a cup, one pebble representing one object, etc. So notice we didn't have the number 0, we don't have any fractions in here, anything like that. So just the numbers you learned in kindergarten, 1, 2, 3, 4, 5, etc., etc. And notice this time after the ellipsis, I don't have another element listed, so this means that this pattern continues forever. So for example, if they want the roster form, let's see, we'll call this set B. Set of natural numbers less than 3. So cap B, so the name of the set, the equal sign, and then the brace to start the set. Natural numbers that are less than 3, well, that only gives us elements 1 and 2. Now another common word used in these is the word between. So let's say that the set C, cap C, I'll make it a little bit bigger so you can tell. So set C is a set of natural numbers between 7 and 9. So I always give the name of the set, the equal sign, and then we're looking at the moment still roster notation. So the only natural number between 7 and 9 is 8. If I want to include the endpoint, I would use the word inclusive. And we'll call this set D. So between 7 and 9 inclusive, so we're including the endpoints, so we'll keep the 7, the 8, and the other endpoint, the 9. So if I use the word inclusive, that means we are keeping the endpoints. If it just says between, that means we are not keeping the endpoints. So next we'll look at a little bit of notation. So a symbol looks like sort of a combination of a C and a capital E. This would be read is an element of. So for example, if set D contains 1, 2, 3 up through 9, I can say that 2 is an element of set D. I can make a similar symbol and say that, let's say 25 is not an element. So if I'm saying is not an element, we put the slash through it. 25 is not an element of set D. Set D stops at 9. So that's a little bit of work with roster notation. We also have what's called set builder notation. So we just give it a name. And instead of listing the elements, we do sort of a recipe, a set of instructions. The straight line is read such that, and then whatever condition or conditions. So I'm just, in set builder, I'm leaving you the instructions on how you would construct the set. So if we say that set E is the set of all x such that x is an element of the natural numbers, so make sure you're familiar with this. Remember, this is the natural numbers. So 1, 2, 3, 4, 5, etc. So x is a natural number and x is less than or equal to 7. So this is what it would look like in set builder. What that same set would then look like in roster form if I were to translate it. So I'm looking for things that are natural numbers and are less than or equal to 7. Well, that would just be 1, 2, 3, 4, 5, 6. And because of the or equals, we will include the 7. So that is what that same set would look like in roster notation. So set F will be the set of all x such that x is an element of the set of natural numbers. And let's say that x is strictly greater than 15. So what I'm going to ask you to do now is pause this and see if you can translate it to roster notation. We already have it in set builder. Translate it to roster and unpause it when you're done. Okay, welcome back. So hopefully you remember that you do still need the label. It does have to be a capital F. So we're looking for natural numbers that are strictly greater than 15, while the next natural number bigger than 15 would be 16. So 16, 17, 18, 19. And we'll have an ellipsis and then nothing after the ellipsis other than the closed brace, because there is no biggest natural number. If you think you found the biggest one, I'll tell you multiply it by 5,000. If you think that's the biggest one, I'll tell you to add 2 to that. And we could keep doing that forever. So the ellipsis is just saying this will keep going in that fashion. All right, so some other topics we want to talk about in our intro to sets. Equality. Set A equals set B if and only if. You'll see mathematicians abbreviate that phrase as if with an extra F, IFF. If you see a math person write that, they're not misspelling the word if, they're using a shorthand for that phrase, if and only if. So it's set A equals set B if and only if they contain exactly the same elements. So for example, if set A contains 2 and 4, and set B contains elements 4 and 2, we can in fact say that set A is equal to set B. They have exactly the same elements. Before we get into the next main idea, we do have to introduce one other topic that helps us discuss it, and that is the idea of cardinality. Cardinality of a set is the number of elements of the set. So notation, N of A, the cardinality of set A. So for example, if set K contains elements A, B, C, and D, I can say that N of K is equal to 4. We have 4 elements in that set. So now that we have the idea of cardinality, just how many items are there in the set, we can get into the idea of equivalent sets. So sets A and B are equivalent if cardinality of set A is equal to the cardinality of set B. So for example, if set A contains elements P, Q, and R, and set B contains elements hat, duck, and pen, well, cardinality of set A is 3. Cardinality of set B also 3. So A and B are equivalent sets. I cannot claim that they are equal. If they are equal, they have to have exactly the same elements. Well, hat and P are certainly not the same element. Q and duck are not the same element. R and pen are not the same element. So we don't have the same elements, but we do have the same number of elements. So they do have some similarities. I can do a mapping from one to the other and some substitutions, things like that. But I cannot claim that they're equal. So equal is stronger than equivalent. Equal means they have exactly the same elements. Equivalent means they have the same number of elements. So another good topic to learn in the intro to sets would be the idea of the empty set or the null set. So let's see, we'll make a little roster notation. We'll practice with our roster notation. So set A will be a set of all x such that x is an NBA player and x is under 4 feet 0 inches tall. So at least as of this recording, we don't have anyone in the National Basketball Association that is under 4 feet tall. So if I were, this would be the set builder version of this, the roster notation, I wouldn't have anything to drop in there. So this is the empty set. So it's sort of a box with nothing in it. One other notation for that, a circle with a slash through it. More often I just use the empty braces. Note here, do not combine these. one inside the other does not mean the same thing anymore. This is a set with 0 elements. This is a set with 0 elements. If you drop one into the other, it's basically having one empty box inside of another empty box. Well, one of those boxes is now no longer empty. One has something in it. So do not combine them. Another note, if we have the element 0, this is also not an empty set. This would be a set with a cardinality of 1. It has one item, the number 0. It is definitely non-empty. Now, one letter that's sort of used exclusively to represent a certain concept is the letter U. U is used in set theory to represent the universal set. Which basically means it's all elements relevant to a specific problem. So for example, if I'm looking at a universal set of 2, 4, 6, 8, and 10, that means for the problems that I'm working with, only 2, 4, 6, 8, or 10 are able to be used for this problem. It's an ugly 4 there, but a 4 nonetheless. So those are some just basic intro problems, some introductory ideas to what we're talking about with sets. Those of you that came through Math97 and South Suburban have seen some but not all of these ideas before. Some suggested homework problems in the text. You can either just use the ebook to find these problems at the end of each section. I can also put up, if the author has some pre-canned homework from the section, the problems won't be the same, but they might be similar. So I would try out 1 to 10 all, and 11 to 83 on the odds. And then next class we'll start with any questions that you have from this and the couple other sections that we're going to do today. Okay, so that's it for this video. If you have questions, feel free to get in touch with me. Otherwise, stay safe out there, and I'll see you next time.